Well, hello. Let's see, I've only done Classwork 1 video, so I thought since we're going to Classroom 3, I don't want to waste too much time here. So let's see. So simplifying square roots and working with square roots kind of go together. So I'm going to go ahead and start with this one. Simplifying square roots. So if you're working on something past the due date, always click Improve Score. Review and practice won't tell you if your question's right or wrong. It won't record any scores, so make sure you always improve score. Now, because my score is 100%, it's actually going to reduce my score because I'm going to be doing it late, but I'm going to click it anyway because I want it to say the right things, I guess. So remember, homework scores are not, they don't go directly to your overall grade. They just allow you to quiz. So what's happening here, let's see if I can pull up a screen sketch here. So, black. So the square root of 12. And the way to do this, we have to factor out perfect square. So to find a perfect square, divide the number by anything it divides by. So I'm going to pick 2 and 6. You could pick 3 and 4. And then I'm going to divide this further. So I'm going to divide the 6 further. 2 times 3. Sorry about my handwriting. I don't have my writing utensil today. So to find a perfect square, we need to find duplicates. So a perfect square is a number times itself. And right here in this 12, we have a hidden 2 times a 2 right here. A 2 times a 2 right here. And so we could write this 12, square root of 12, as the square root of 4, which is this 2 times 2, times the square root of 3. And the reason why we want to break this 4 apart from the 3 is this is a perfect square. In other words, the square root literally asks what number times itself gives you this 4, and that number is this 2 right here, this 2 times 2. So the number times itself that gives us 4 is 2, and so this will simplify or square root to become a 2, and then the 3 we'll leave alone. The 3 does not square root evenly. It's a irrational expression, the square root of 3, irrational number. So this is going to be our most simplified answer. They're asking us to simplify the expression, simplify the radical expression. Okay, so we're gonna this is the simplified answer. 2 times the square root of 3, so that's what I'll type in. 2 square root 3. All right. So this one's similar. Now with this one, I think of the square root of 175. I think it was like $1.75, right? Imagine we broke this into 25 like quarters, right? 25 cents. And the reason why is I know that 25 is a perfect square. This is 5 times 5. So I know that will square root evenly. And then, but how many quarters is it? There's 4 quarters in 100, so this is 4 plus 3, so that's 7 quarters. Okay, so then once we see it that way, this is what's going to square root evenly, right, as a 5. This 25 is perfect square right here. 25 will square root as a 5, and the 7 will stay behind. So this is going to be our answer. So once you kind of can see the perfect squares and tease them out, it's very quick to get to the answer. So the square root of 175 is the same as 5 times the square root of 7. That's important to know. It's an important skill to be able to develop. So maybe, roll similar questions quite a few times so that you can start doing this more quickly. All right. Question 3. This gets a little more tricky, so I'm going to go through this a little bit slower. It's the same idea, though. We're hunting for perfect squares. Square root of 18 times x to the 9th. So 18 is 9 and 2. And 9 is a perfect square. So this is going to square root as a 3. So that's going to come out as a 3. and then this 2 is going to stay behind. So that's kind of like what we did before. I'm going to put some space. Whoop, that 2 stays behind. So this would be the answer, except we have this x to the 9th here. This x to the 9th we have to deal with. So what's happening with x to the 9th is that's x times itself 9 times. Oh, it's going to be painful to do with this mouse. 6, 7, 8, 9. Okay. And then each time there's 2, that's a perfect square. That's a factor times itself. So we have a bunch of perfect squares in here. This is like x squared, x squared, x squared, x squared. So each of these, when you square root them, will produce an x. So once this is square rooted, each of these will drop out an x. So these x's will come out in front. There's 4 of them, so when we multiply them back together, we get x to the 4th. And then there's 1 x left over, that x stays behind. So this is what the answer looks like. Okay. So the things that we couldn't square root evenly, this 2 and that x, stay behind. Everything else is a result from square rooting evenly. All these perfect squares came out. The 9 created a 3, and these 4 pairs of x's created this x to the 4th. So we could have just, anytime you have an even number, so the 9 is an odd number, so we have to take one off, but the remaining even x's can always be divided in 2 to create the exponent of the square rooted result. So we'll look at that on another one. Oh, what am I doing? What am I doing? Okay, here we go. 3x to the 4th. And I use the arrow keys to get back down. Sometimes it's hard to get out of the exponent. Make sure when you're using square root, use this one and not that one. This one's for roots other than the square root, but we're dealing with square roots right now. So make sure you're using this one that doesn't have that little blue box. Make sure it does not have the one that does not have the blue box. Okay. 2x. Next question. Okay. So this is kind of similar to what we just did before. I'm going to do it kind of quickly because you can look at the one previously if you need extra help. So I always copy down the problem, which is I recommend doing. So 48, there's a 4 in there, right? 4 and 12. And then there's another 4. So there's actually a hidden 16 here. There's 4 times 4. So it's a perfect square right here. So that will square root as a 4. And this negative 29 is not going anywhere. Negative 29. Oops, it's supposed to be a 9. There we go. There we go. 4 times negative 29. And then this x to the 13th, I'm going to break that apart as x to the 12th times x. So this x to the 12th will square root to x to the 6th because it has 6 pairs in it to create a 12. And then what stays behind is this 3 and that x. So we have 3x that's left behind. Now, we're almost done. It said this negative 29 has to be multiplied to 4. So 4 times 20 is 80, and 4 times 9 is 36. So 80 plus 36 is 116. So negative 116. So this will be a negative 116. X to the 6th, square root 3x. So that's going to be our answer. Okay. 6. Oops. Let's see if I did that right. And I did. So I went through that pretty quick. Feel free to always rewind or slow down if something doesn't make sense, or ask me a question. You can always ask me a question in class. This is, what was this number? 1.1a.15, so 1.1a.15. So you can always, I can find that problem if you use this little problem catalog number thing. All right, this is really easy. They're just showing you that you can break it apart That's all that is. This one's also the same. If you have fraction or radical, you can break it apart into two separate fractions. Not two separate fractions. Two separate radicals, I should say. You can also put them back together. This one, let me do some question. So, 43 here. 48, what I'm trying to say here. 48 can be broken apart to, let's do 4 and 12. So here's 12 times 4. And then 12 can be broken apart as 3 times 4. So we just did this one. These 4s are perfect square. And these 3s are perfect square. This 3 is included because it's also in a radical. So it's hard to see. I kind of messed up that 3. This 3 and that 3 are included. So these 3s are a 9 that will square root as a 3, and these 4s are 16 that will square root as a 4. 3 times 4 is 12. So the answer is going to be 12. So just treat it as though they're under one radical, I think is the... You could also do 3 times 48, which is 144, the square root of which is 12. It's another way to think about it. This is the same idea. So 3 times 75, what is that? I don't know off the top of my head. Well, let's not do it that way. Let's do it this way. 75 can be broken up into 3 times 25. So look at that. 25 is a perfect square, and so are these 3s. So we're going to, this 3s make a 9. 9 square rooted is 3. 25 square rooted is 5. Oops. Supposed to erase. Small eraser. Whoop. There we go. 3 times 5, and then this y to the third and y to the fifth, there's 3 y's being multiplied here, and 5 y's being multiplied here. So together there's 8 y's being multiplied, and when you square root it, it just divides in half. So we get y to the fourth. So 15y to the fourth will be our solution for this one. Okay. All right. Let's see. This one's really easy. It looks hard, but what you have to understand is powers and roots are inverses of each other. So the power and the root will cancel out. And this is really just 5b times 7b. 5 times 7 is 35, and b times b is b squared. So that's the power. This is kind of an introduction to rules of exponents, or exponent rules. And so powers and roots are both forms of exponents, and they work against each other. And since they're equally powered, there's a square root and this is a square power, they cancel out. This last one just breaks apart. The square root of 25 is 5, and the square root of 36 is 6. So you can break them apart and square root them each separately. So that's it for simplifying square roots. I hope this was informative. If not, please ask questions from your neighbors or with me in class. Thank you.